y. I'll just evaluate it. Your final answer was y equals negative 3x plus 8. For part B, if you look at that slope field, the only horizontal asymptote exists right here at y equals 1. Letter C was exactly kind of like number 32 from your homework. So you had to take your antiderivatives, get your natural logs with your C's, use the initial condition, find your C, plug your C back in, E both sides, take into account that that E ln 5 over E becomes your C up in front because the E's and the ln's cancel. And then use that to find the limit as it goes to infinity. So something really, really big dividing a constant is really, really small, therefore like 0. So that acts like e to the 0, which acts like 1. Again, they sort of cancel out and give you your 5. In part D, this was actually super easy. You just had to plug in -1 and get a slope. So remember that this represents the slope of the tangent line. So if this represents slope and they give you the point, you just plugged it in. A particular solution given multiple parts and given y's and x's meant you had to separate your variables and take your antiderivatives. Separated variables, antiderivatives. Finding C, getting your final equation, and again taking into account whether you had the positive or the negative part of our circle. And again, this side is the positive side, because our point 1/2, 3 was in quadrant 1. So letter F was really taking into account understanding both that this represents slope. It's not separable, therefore you couldn't move the y's and the x's apart. But the idea that this is a linear particular solution tells me that my second derivative had to be 0. If the original gave a linear solution, then that means by the time you get to your second derivative, it was 0. Thus, that gets you to the point where we have dy dx, d2y dx squared. So you could actually find that second derivative, and you get 8 minus 2, and remember back to implicit days, d2y dx squared, derivative of 8x is 8, dx dx, which is 1, minus 2y prime, or dy dx. But dy dx is 8x minus 2y, so we plug that back in through substitution, and we get that our second derivative is really this 8 minus 16x plus 4y. But but we know that it's linear, therefore this has to equal 0. So then you can use that to solve for y, and boom, y equals mx plus b, or 4x minus 2. So find m plus b. Well, here's your m, here's your b. So it has to equal 2. I think that was on the 2016 or 2017 AP exam. Most of the questions on this Big Ten review packet came from past AP exams. Most of this Big Ten packet came from past AP exams. So again, we are in April. April is AP month, so everything we're going to be doing is with respect to that AP test now. Now, letter G said which of the following could be the slope field. So this was a multiple choice question. I just changed it to numbers. And we had dy dx equals x minus y. So again, what I would do is plug in points to try to eliminate slope fields. So when I look at this slope field here, number 3, well, that slope field I can tell definitely has some sort of asymptote happening in the middle. These slopes are positive, these slopes are negative. So if I pick a point up here and I plug it in, I need to have a positive number, and when I plug it in I get 0. Therefore, goodbye. And then that actually also eliminated 9 because there's no zeros in here either. So it got goodbye. So then I picked a negative point over in this, actually over in this spot, so that I could eliminate 5 because, again, I got a positive and all of those slopes are negative. Thus making 7 correct. And I can see here y equals x would give me zeros, because it's x minus y, and I have all zeros on that y equals x line. Letter H. Guys, letter H was linear approximation. That was in chapter 3. So once again, the idea here is tangent lines. I told you from the beginning of the year, tangent lines are a huge part of this. They're always y minus y1 equals mx minus x1. So if you're trying to approximate with a tangent line, then this sort of represents your y2. This is your x1, y1, and there's your slope. So plug in your points to get your slope at that point. So that's how I got this number 2. Then plug in your x1 and your y1. So again, everything's always going back to point slope form. From back in the day. Okay, this was a calculator problem. Do not try to do this on by hand. I sort of wrote down parts to help you, but if this were an actual question on your test, use the calculator, type this into y1, or just type it right onto your calculator. There's my calculator. So what I would have done was said, okay, I will have dy dt, or dw dt. I'm trying to find dw squared d2 squared at 14. So, again, can you do it by hand? Yes. And do you have to do a little bit by hand? Yes. Do you have to do all of this by hand? No. So what you did have to take into account was the 2 days and 20 weeds. So here you could have distributed your 1/12. You can leave it out in front. Doesn't really matter. Take your derivative and then plug in your 2's and your 20's and get GW of 14. Okay, letter J. This one, I believe, came off the 2017, number 6. Again, this was one of those packets we did at a NIMSY training a couple years ago, so I think these were 2016, 2017s. So I give credit because I did not create this one. Okay, questions, comments, concerns, feeling better about everything from chapter 6. I believe you're going to actually like day 1 of chapter 7. It's everything in day 3 that kind of tumbleweeds into more confusing sort of stuff. So we're going to do a lot of geometry in chapter 7. So for today, we're looking at a ton of geometry. Okay. So 28, you had negative 1/2 cosecant 2 theta plus 3/2. 30, you had sine t minus 1/2 t squared minus 2t minus 1. And then 32, we had the final answer of y equals 2e(x squared plus x minus 1. Yes. So that one kind of came from the fact that if you had your ln up top for your c value, so like c in here, like where we have this c. So I'm opening up our book too, so I could and then I plug in my numbers, and we get c is equal to 1. That 1, when we e both sides, is up here. And then when you separate it all out, it kind of comes down and replaces your c. Here, I can work it out for you on different notebook paper. And I'll start kind of. So do you have this line to here? Thought I had notebook paper back here. There's some notebook paper. Okay, so you have two sort of choices about when and where you want to plug in. So we were given that y of negative 1 was equal to 1. So you could plug it in now and say, okay, the natural log of negative 1 plus 1 equals, negative 1 squared plus negative 1 plus c. So 1 plus 1 is 2, so you get the natural log of 2 equals, and then negative 1 squared is 1, minus 1 is 0, so we get c is equal to the natural log of 2. So then you go back to our line here, and it's the natural log of y plus 1 equals x squared plus x plus the natural log of 2. So to solve for y, you have to e both sides. So here the e and the ln cancel, leaving you with the absolute value of y plus 1. And here you have e to the x squared plus x plus ln 2. But anytime you have e with things being added together, that is the equivalent of all of those being multiplied. So e and ln's cancel, so that ln of 2 becomes the initial condition, or that c value out in front of 2. So this becomes e to the x squared times e to the x times the number 2 because of this canceling property, with that absolute value of y plus 1 tagging along. To get rid of absolute values, you take plus or minus to both sides. We like to rearrange our terms so the number is out in front. So you get y plus 1 equals plus or minus 2 e, and we're never going to leave 2 e's in there, so we go back to adding our exponents and then isolating y by subtracting the 1 from both sides. And then the reason this is only the positive in our answer is because going back to that initial condition, since my y value in the beginning was a positive, then I only need the positive for my final answer. And we're done. Better for 32? Good. Okay, so while we're on that, 34, I'll just write down the answer for you. 34 was y equals 100 over 1 plus 19e to the negative 0.1x. So again, in number 34, you were given dy dx. You had to sort of multiply, then get your y's to the left, and then you had a constant on the right. And then again, you had to ln both sides, and in this case, it just dropped that down inside. So 34, if we look at that, so what I would do to start is take that 0.001 and multiply it by 100. And that leaves you with 0.1 y minus 0.001 y squared. And then we need this all to be with the dy's. So you can do one of two things. You can just divide everything and leave a 1. So I would rewrite that as 1 over 0.1y minus 0.001y squared equals dx. And then you can integrate both sides. And the minute we have this situation here with the bottom terms being with the top terms, you know you're going to need a natural log. What makes this natural log worse is that since you have y squared here and no y up there, you actually have to do like the double setup where you say, okay, u is equal to 0.1y minus 0.001y squared. And then u prime is equal to 0.1 minus, and then you get 0.001 times 2, which is 0.002 y dy. So obviously we're missing all of this sort of up top. So that's where you have to go back in and do the ideas with your u subs. So we know it's 1 over u, but we're missing the y up top. So that's where you go back and you sort of solve for your y up above. So is everybody okay so far? Like, kind of see what we're doing? Okay, so go ahead and looking here, you could factor out. Do we like decimals or fractions? I feel like I would use fractions, but it gave it to you more or less as decimals. And then if you look, we're still sort of missing that 2. So you could take out the 2. I feel like this would also be maybe a BC question. It's very, I know, because it's very hard to like explain it and not try to confuse you like as I'm working through it. So the idea would have been personally to do it with completing the square, but that technique is a BC technique and they actually pulled it from AB. But again, we're getting new books to try to pull those BC questions out. I'm trying to think if I would have started you a little differently up here, if I could have made this easier for you. What? If you had maybe not distributed your 0.001, let's get rid of our fraction. Are you ready? Don't distribute your 0.01, just distribute your y. That way we don't have to work with decimals. Okay, anybody keep it like that? And not distribute the 0.001? Yeah, is that what you did? Yeah. So after I multiplied it in, I was like, and then you sort of start to get your crazy decimals. If you had kept it more like this, then you can avoid all of those crazy decimals. And I want to look to see if our textbook had them do completing the square as opposed to the other technique. And if that's the case, I'm going to tell you not to stress this one so much. It does. It has you do completing the square and partial fractions. So super sorry. You could have skipped. I had you skip 36. I wonder if I wrote down the wrong skip. I did. It should have been skip 34, not skip 36. I'm so sorry. Because 36 you could have done. It was a fundamental theorem. Sorry about that, kiddos. 34 was a partial fraction, which is no longer on AB. I'm so sorry. It's okay. Well, if you take Calc 2, you have to learn this next year. So just know if you're taking Calc 2 in college, this is coming. Okay, 38 was a slope field. And then 40 and 42 were some multiple choice AP practice. So you got D and A. And then 51 and 52 were our Newton's law of cooling and our half-life laws. So in 51, your final answer was 26.2 for part A, or 0.262, sorry, for part A. And then 3.8159 years for part B. And then in 52, you had approximately 106.94, which rounded to the nearest minute was 107. Yes?
In your second part of 52, why is the 180 not 44?
In the second, for part...
Like the third line in your second part. I don't know how to explain it.
This one.
Yes. Why is the 180 not subtracted completely?
Okay, so let me...
I didn't know if that's filed wrong or...
I'm trying to see like how you, or why you did what you did.
I just use the same equation.
So you're saying I have, so here, you had 180 minus 40 instead of 70 minus 40?
Yeah, 70 minus 40 equals 180 minus 40 times.
Because in part B, are you sure it was 180 for that second part, not 220? Didn't I do 220 minus 40 to get 180?
But isn't 180 the original temperature for that one? Because it's cooling from 180.
Well, I look in the book at what the actual wording is. Because I only have written down like what I did for my work. So I have to actually go read for part B. So it said, how long did it take the pie to cool from there to 70? So 15 minutes later, the pie's internal temperature was 180. How long did it take for the pie? No, because 180 is the temperature right there. So that represents Y initial. So if the pie's temperature here is 180, so it says how long does it take to cool from there? Well, there is 180, not 180 minus 40 more degrees. This is the temperature at that second starting point. Look, do you see what I'm saying? Let me think about how to reword that to explain it. So, remember I said I did 220 minus 40 because 220 was the original starting temperature.
Yeah.
So in the second part, it said how long does it take to cool from where we are 15 minutes later. So the temperature of the pie 15 minutes later is 180 degrees.
But isn't that the same thing as in part 1? except the only difference is it's 180 degrees instead of 220. That was the question I was originally asking.
But you told me you had 180 minus 40 here.
Because if you use the same equation, it's, instead of being, it's just the same equation for the 180 instead of 220. So wouldn't be the same thing. That was just, I don't understand why that would be the same.
Because technically this is still 220 minus that 40 degrees. Because we're now, it's what? Yeah, these two things aren't comparing the same. Like this represents the temperature of the pie at time 15.
The answer I got was the one right in the back of the book. Or
It's an
online then.
Yeah, because the back of the book answer is 107.
No, but if you on the middle, it is. I thought it was
107.
on the.
Because I'm looking at the answer at the back of the book right now.
I think it's because you already did the initial temperature,
So
you're
you-
trying to do.
If you take but that's what I was trying to get at. If you take 15 minutes from my 107, you will get 92. Which, if you let me just scroll down, I tried to explain.
So the way I did it, you're wrong.
Like, when you did it,
Well, the way Slater did it is
Same answer. Well, no, I actually did this one.
okay. So no, it's just that the way the way I set up and the way you set up aren't different. The way I set it up was to get the time it took to cool to that temperature overall. Then I took into account the fact that this represented 15 minutes later, therefore giving that 92. So the 107 is the time it takes to get there, and then you have to take into account your initial condition.
Yeah.
So that's what I was trying to say. I didn't set it up yes. What you did is okay. We just set it up and thought through it differently.
This is the only one thing I understood. I'm wrong.
I did say you were right. I was just trying to figure out why you had a different number here than I did. And I had to go back and re-look at the problem.